Your boys, good morning. Welcome back to our online class. We were just in our review class, we were having review classes on different chapters, different topics, and in our last class, we had discussion on chapter 1. Creative type question was discussed, and today we will continue with chapter 2, that is motion, an important chapter for your board exam. And as we have reviewed already this chapter before, today we will try to solve some other creative type questions only. And as all of you know, if you just follow the questions of last couple of years, that means the board questions of last couple of years, there is a trend of question from graph based or diagram based question comes most probably. So we will try to discuss some question related to graph or diagram. So our first question is first creative type question is here. The same is related with a graph. Here the graph shows velocity versus time for two curves. This is the graph here or diagram here. The graph is showing the velocity versus time graph for two curves. First curve OAB line is for first curve and the CD line for the second curve. If you just follow the diagram here, OAB, this line is for first one, and the CD, this line is for the second line, second curve. So what are the questions related to this time? First of all, number A, what is periodic motion? Number B, why the traveling distance is not equal when same amount of force applied on different mass bodies. Number 3, determine the acceleration of the first car. And number D, which car is traveling more distance in 30 seconds. So these are our questions, and this is our stem, and now we will just try to solve the question. And question number A, this question is actually a board question that came on last year. Question number A answer: what is periodic motion? If the motion of an object is such that it passes repeatedly through a definite point in the same direction in the same manner in a definite interval of time, then this motion is called periodic motion. There are many kinds of motion. Periodic motion is one of them, and this is an important definition. That means periodicity is maintained here within definite interval of time. That is called periodic motion. Question number B, why the traveling distance is not equal when the same amount of force applied on different mass bodies. Here the bodies have different masses, but we are applying same amount of force on all the bodies. So as the masses are different, we know from our familiar equation F equals ma. For different masses, if we apply same amount of force, the acceleration will be different here. So when the same amount of force is applied to different mass bodies, the bodies get different amounts of acceleration, and this acceleration tends the body to move with different velocity. Different acceleration produce different velocities to the bodies, so the bodies travel different distance as their velocities are different. So they just travel with different distance within the definite time. So this is the reason why because of applying the same amount of force, but as the masses are different, so they have the bodies have different acceleration, then different velocity, then different distance. Number C, determine the acceleration of the first car. Question number C is the determining the acceleration of first car. As we know from the equation of acceleration, or from the definition of acceleration, um, acceleration A is equals v minus u by t. That means change of velocities within a definite time, and that is called acceleration, or change of velocity per unit time, that is called acceleration. If we just observe the diagram for a for the first curve, that is the curve under OAB. So here the initial velocity from the graph is 0 meter per second, and final velocity is 40 meter per second. As from the x-axis, we just have the values of time, and from y-axis we just get the values of velocities. If you just follow this line OAB, here the velocities is rising for first 20 second, and within this time the initial velocity starts from 0, and the final velocity ends at 40 meter per second. But for the rest of time it is following uniform velocity, there is no change in velocity. So for this reason we will count the initial velocity as 0 and the final velocity as 40 meter per second. So here the acceleration will be 2 meter per second square. And our question number D was, which car is traveling more distance in 30 seconds? For 30-second time, which car is traveling more distance? If we just manage here the 30-second graph, instead of counting the point P, we are getting a new point here. We just draw a line over here. We are getting a new point E. So for getting the distance traveled, we have to measure the velocity time graph, area under the each curve. That means for first curve, the curve is the area under OAE. This curve is for the first curve. So for determining the distance, we'll just count the area under OAE, this portion. So for determining the distance for first curve, the area is OAED. If we just measure this area, this is just trapezium. So for determining this area, we will just use the law for trapezium, and here is the equation: half into AE plus OD into ED. This is the equation for the area of trapezium. And so finally we get the length area AE. What is the length AE? That is, if we just get this one OE, and we just minus the term OA, from that we will get the value of AE. We are just minus doing calculation here. That means if we consider this OD and minus OA from that, then we are getting the values of AE plus OD into ED. And if we put the values here from the graph, we just follow here, the area will be 800 meter. The distance will be 800 meter. So distance traveled by first car is 800 meter. And for the second car, as the second car the graph is CD. The portion for second car is CD. That means the area under CD curve will be the total distance for the car, second curve. So for second curve, area of OCD under the curve CD, the total area is covered by OCD. Then this is from this one we just get the if we just use the equation, half into OD into OC, that means base into altitude, then we just get the values here. 900 meter. So distance traveled by second car is 900 meter, but the distance traveled by first car is 800 meter. That means the second car travels more distance here, because for 30-second time the first car is moving with increase in velocity for first 20 seconds, but for the last 10 seconds it moves with uniform velocity. We are just counting the fact here. And for the second car, if we just have the calculation, we are getting that the distance is 900 meter, and from this calculation we can say that second car moves more distance for the same amount of time. That means for 30 seconds the second car moves more distance. This is the first STEM based math, or first creative type math of today's class, and now we will just try to see the second one. What is the question over here? Here the opposite one is here, that means the list or the table is given for you. You have to determine the graph here. A list of velocity and time of a car is given below. Time and velocity. Time for 0, 2, 4, 6, 8, 10, 12, 14 for different time. The velocities are 0, 5, 12, 12, 12, 8, 4, 2. These are the velocities for different time. And according to this STEM, question number C, determine the distance covered by the car in first 8 seconds. And question number D, draw the velocity versus time graph using the list and analyze the change of its velocities. So question number C, we have to determine the distance covered by the car in first 8 seconds. For first 8 seconds, the initial velocity is 0, and the final velocity is, for 8 seconds the final velocity is 12 meter per second. Time is 8 seconds. So for determining the distance we will use the equation of motion as equals ut plus half a t square. And the value of u and t are known to us, but what will be the value of acceleration a? We will use the equation a equals v minus u by t here, and applying this equation we just get the value of acceleration is 1.5 meter per second square. So finally the distance for 8 second time will be 48 meter. If we just have a calculation here, the distance traveled by the car within 8 second time will be 48 meter. And then question number D, draw the velocity versus time graph using the list and analyze the change of its velocities. Velocity versus time graph, we will have to draw the velocity versus time graph using this list, and we have to explain about the change in velocities here. So for this type of question you must use the graph paper, and if the graph paper is supplied to you on the exam, you must use the graph paper, otherwise you just make it with your free hand. So at first we just follow the list, and then we just try to make a graph from this. Listen boys, in x-axis we are putting the values of time t, and on the y-axis we are putting the values of velocity v. So for the times are projected here, 2, 4, 6, 8, 10, 12, 14, etc., and the velocities are projected on y-axis. As for this time, the velocities are ranges in a different range. that means periodicity is not maintained here. So we are just dividing it that half, 5, 7.5, 10, 12.5, 15, etc. here. And now, according to our table, or according to the list, we will try to draw a graph. From the table, for 0 second time the velocity is 0. For the time 2 second, the velocity is almost 5 here. For 4 second, velocity is 12, and that means a little bit less than 12.5, and we are assuming that this point is 12. For the velocity for the 8 second time, the velocity is same here, that is 12. And for 10 second time, the velocity is same here, that means 12 meter per second. But for 12 second, for the time of 12 second, the velocity has reduced to 8 meter per second, and then 4, and then 2. For the 14 second time, the velocity has finally reduced to 2 meter per second. So if we have got the points over here, and then we just project the lines, then we just get the graph like this. So from this graph, we have to analyze the changing velocity. There, if we observe the graph over here, from this point to this point and to this point, that means from O to A, in this region, the velocity is increasing with time. That means acceleration is happening here for 0 to 4 seconds. This change is happening for 0 to 4 seconds. And for next 6 seconds, that means from 4 to 10 seconds, there is no change in velocity. From 4 to 8 seconds, 8 seconds. So as there is no change in velocity, this within this region the car moves with uniform velocity, and the region AB is projected here. In this region, the car moves with uniform velocity. But after this point, that means from 10 to 14 second, the car velocity of car reduces again, and that means instead of having acceleration, deceleration happens here, and the graph BC indicates the retardation. So these are the total observation about the velocities of changing velocities of the curve within the different time periods. And if we are told to measure the acceleration here, then we could measure it by at different point. Sometimes this is told to us that for different points, just measure the acceleration or calculate the values of acceleration. So we can easily do that. As in this question, this is not mentioned to us, we have no need to do so. If it's told to us, it is if it is just mentioned to the question, then we will do that. So boys, these are the two questions related to graph, related to a chart, related to list from chapter 2. And we will continue review class on our next week also, because as we have some more classes before your second in-house test, and we will continue reviewing on those classes. Boys, that's all for today. Take care, and have good preparation for exam.